Hello dear students, welcome you all. How is everyone? Are you able to hear my voice? Are you able to see the video? Audio video okay? I think audio video are okay. So let us start our next lecture, lecture number 8 of Prelims PYQs. So engineering services prelims questions are being discussed in this session, and complete questions of strength of materials will be discussed in this series. And this is the second chapter in the series, shear force and bending moment. So 2 classes are already done for shear force and bending moment. This is the third class for shear force and bending moment. And in this class, we will be discussing ESE prelims questions from 2003 to 2007. Okay. So let us start discussion. Question number 1. If the shear force diagram of a simply supported beam is parabolic, then the load on the beam is. Okay. So if shear force diagram is parabolic, so you already know that SFD is 1 degree higher than the loading diagram. Okay, shear force diagram is 1 degree higher than loading diagram. Okay, also bending moment diagram is 1 degree higher than shear force diagram. Although this part is not needed in this question. In this question we only need that shear force diagram is 1 degree higher than the loading diagram. Okay, so if shear force diagram is given parabolic, shear force diagram is given parabolic, that means it is 2 degree curve. Okay, so if shear force diagram is given as 2 degree curve parabolic, then loading diagram will be 1 degree less than that. So loading diagram will be 1 degree curve. 1 degree curve means it will be a straight line, or the shape will be triangular shape. Okay, so 1 degree or triangular shape, that means it will be like this. Okay, it will be like this. When it is like this, that means it is uniformly varying load. Okay, I have not drawn the supports because irrespective of the supports, irrespective whether it is a simply supported beam or it is a fixed beam, okay, the shape will be linear. Okay, when shape is linear, that means it is varying from 0, or may not be varying from 0, but it is linearly varying. And when it is linearly varying, we can say it is linearly varying distributed load. So correct answer will be option D. Clear to all? Are you able to understand this question? Okay, any doubt? Let's move on to the next question. So second question, the bending moment for which the beam shown below is to be designed is. Okay, so we have to find out what is the maximum bending moment for this beam. Okay, in order to know what is the maximum bending moment, let us draw the bending moment diagram for this beam. So how to draw the bending moment diagram? Bending moment diagram can be drawn very easily. Just a minute. Okay, so these are the reference lines. These are the reference lines. Okay, so these are the reference lines. Now if I have to calculate bending moment at this location, it will be minus w x square by 2. Let us say that this distance we are taking as x. Okay, if this distance is x, at this location we will be getting bending moment as minus w x square by 2. So minus w is 100 into x square, x is 2 divided by 2, 2 square by 2. So it will be minus 200 kilonewton meter. Here the maximum bending moment will be minus 200 kilonewton meter. Okay, similarly it is symmetrical, so at this location also we will be getting minus 200 kilonewton meter. So it will be minus 200 kilonewton meter. Okay, now bending moment diagram will be something like this. Bending moment diagram will be something like this. Okay, so at this location we have to calculate bending moment. Okay, these are the only 2 locations where we can have maximum bending moment, and out of these 2, whatever bending moment is the maximum, that we will take. Okay, so if we calculate bending moment at this location, first we have to calculate the reaction. Either from this side we can calculate, or from this side. Okay, let us calculate support reaction at this location. Total length of the beam is 8 plus 2 plus 2, yani 12 meter. Okay, so total downward load will be 1200 kilonewton. This is the total downward load. So if 1200 kilonewton is the total downward load, support reaction here will be 600 kilonewton. Now if the support reaction is 600 kilonewton, bending moment at this location will be, it will be minus W minus 100 into, what is this length? 8 by 2 4, 4 plus 2, 4 plus 2 6. So minus W into 6 square by 2. Are you able to follow now? Because of this UDL, how much bending moment we will be getting? Because of this UDL, I will be getting minus W x square by 2. So at this location, x will be 4 plus 2, 6. So minus W x square by 2, in place of x I will write 6. So minus W minus 100, W is 100, okay. So minus W 6 square by 2 plus, now because of this, I will be getting positive bending moment. So positive bending moment will be 600 into this length. So 600 into 4. So plus 600 into 4. This will be the bending moment at this location because of this, okay, because of this support reaction. Now if I calculate, it will be minus 100 into 36 by 2. So minus 1800, minus 1800 plus 6 4 are 24, 2400. So 1800 minus 2400, it will be 600. So here I will be getting 600 kilonewton meter. Okay, so all these calculations you must be able to do very quickly. Okay, so 600 kilonewton meter is the correct answer. Correct answer will be option C. So I hope you are able to understand. Let's move on to the next question. Next question, assertion reason. Okay, assertion: a horizontal beam hinged at one end and freely supported at the other end will be in static equilibrium under inclined load applied on it. Okay, so if I am having a beam, see which type of beam, support condition. Let us first see what is the support condition. Okay, so support condition, horizontal beam, what is the support condition? Hinged at one end. So this is hinged at one end. Let us say this is the hinged end, and freely supported at the other end. What do we mean by freely supported? Freely supported means roller support. Roller support, it is free support. Okay, so freely supported at this end and hinged at this end. Okay, it will be in static equilibrium under inclined load applied on it. Okay, so let us apply an inclined load. Let us apply an inclined load like this. Now under this type of load application, will it be stable or not? Will it be in static equilibrium or not? Static equilibrium means it is not moving. Okay, it is in equilibrium, but it is static means ruka hua. It is not moving. Okay, so static. Okay, so will it be in static equilibrium? Yes, it will be in static equilibrium. It will be in static equilibrium. This support will be offering how many reactions? This support will be offering two reactions, one vertical reaction and one horizontal reaction. This support will be offering vertical reaction. Okay, now this inclined load will be having two components. Okay, what will be the two components? Two components will be, one will be vertical component and one will be horizontal component. Okay, so this horizontal component will be resisted by this horizontal support reaction. This vertical component will be resisted by these two vertical reactions. Okay, so that means it will be in static equilibrium. So assertion is correct. Assertion is true. Okay, now reason: the hinged end will offer resistance to the horizontal component of the applied force. Okay, so we have already discussed that this is the applied force and this is the horizontal component of this applied force, and this hinged end will resist the horizontal component. So that is why it will be in equilibrium, static equilibrium. So this is also true, and it is correct explanation also. It is correct explanation also. Okay, so correct answer will be both assertion and reason are true, and R is the correct explanation of A. Correct answer will be option A. Clear? Let's move on to next question. The diagram below shows a simply supported beam with load. Okay, so this is the simply supported beam and it is loaded as shown. So here we are having uniformly distributed load over half beam, and the magnitude of the load is 100 kilonewton per meter. Intensity of loading is 100 kilonewton per meter. So this is the intensity Can you tell me what is the total load? So total load will be equal to intensity of loading into the length multiplied by the length over which this loading intensity is there, over which this load is acting. So this 100 kilonewton per meter is acting over a length of 1 meter only. So total load will also be 100 kilonewton only. Now, which one of the following diagrams is the shear force diagram for this beam? So we have to find out the shear force diagram. Let us first draw shear force diagram ourselves, and then we will look at the options. Okay, so let us first draw the shear force diagram ourselves. How we will draw the shear force diagram? First of all, we have to find out the support reactions. Okay, so let us say this point is A, this point is B, this point is C. Okay, so support reaction RA and RC we have to find out. Okay, what will be the value of RA? So RA will be equal to RA will be equal to, if we convert this load into point load, if we convert this load into point load, it will be 100 kilonewton point load. Okay, 100 kilonewton point load. Okay, this load can be converted into 100 kilonewton point load. So this UDL can be removed now. Okay, so just visualize that it is removed. Okay, only point load of 100 kilonewton is acting. Now what will be the location of this 100 kilonewton? It will be at the centroid of this. That means from here it is 0.5 meter, from here it will be 0.5 meter. So this distance will be 0.5 meter, this distance will be 0.5 meter. Okay, now since we have converted this into point load, we can find out support reaction RA as load into opposite length divided by total length. So what is the load? 100 kilonewton into opposite length is 0.5 meter divided by total length is 2 meter. So 100 into 0.5 divided by 2, it will be 100 by 4, that will, it means it will be 25 kilonewton. So RC, total load is 100 kilonewton, RC will be 75 kilonewton. 25 plus 75, 100. Okay, so RC will be 75 kilonewton. Okay, now if I want to draw the shear force diagram, how will shear force diagram look like? It will look like this. Just a minute. Let me draw the reference line with this color. Okay, I'm always using this color for reference line. Okay, so this is my reference line. Now if I draw the shear force diagram, okay, just a minute. Anyways, so RA, because of this RA, my shear force value will be going up by how much? 25 kilonewton value. Okay, so my shear force value will be having a sudden jump here, and jump will be of 25 kilonewton. Okay, now from A to B there is no transverse loading. Okay, since there is no transverse loading in this portion, my shear force will remain constant. So this will be constant from here to here. Okay, so this region will remain constant. In this region, shear force will remain constant. Now again transverse loading is there. Now remove this 100 kilonewton. Okay, now the variation we have to plot. Okay, so now we have to consider this UDL. Okay, so from here to here we are having transverse loading. Again, this is the actual applied transverse loading, so we have to consider this, and shear force will be changing because of this, but shear force will be changing slowly, linearly. Okay, shear force diagram will be 1 degree higher. Since this is constant, our shear force diagram will be 1 degree higher. That means it will be x to the power 1. That means it will be linear, means it will be straight line. Now this loading is downward, so it will decrease the shear force by how much? By 100 kilonewton. So in this portion, over the length of this portion, my shear force value will be decreased by 100 kilonewton. So here I am having 25 kilonewton, and from here to here, my shear force value will be reduced by 100 kilonewton. So 25 kilonewton reduced here, here it will be 75 kilonewton, so it will become minus 75 kilonewton. Minus 75 kilonewton. Okay, so this part will be positive, this part will be negative. Okay, so shear force diagram will be like this. So let us see shear force diagram. Now sometimes what they do, they just reverse. Okay, it is positive, but they draw in question. Sometimes it happens that this positive they draw downwards and this negative they draw upwards. Okay, so correct answer will be option B. Correct answer will be option B. Okay, let's try next question. Okay, in which one of the following the point of contraflexure will not occur? Okay, so we are given some cases, option A, B, C, D. Okay, so in which of the following the point of contraflexure will not occur? So let us first draw this two span continuous beam. So two span continuous beam. Okay, I am having two span continuous beam of equal span. This span, both are equal span, simply supported and loaded by UDL over both the spans. If the beam is like this, then the bending moment diagram will be something like this. Bending moment diagram will be something like this. Okay, so in this beam we will be having 2 points of contraflexure here. These are the point of contraflexure, right? Next, a simply supported beam loaded by UDL. So we are having a simply supported beam. Okay, it is loaded by UDL. When simply supported beam is loaded by UDL, then the bending moment diagram will be like this. So here there are no points of contraflexure. So point of contraflexure will not occur in option B. In this simply supported beam loaded by UDL, there will be no points of contraflexure. So correct answer will be option B. Fixed beam loaded by UDL. So when a fixed beam is loaded by UDL, fixed beam, let us draw fixed beam loaded by UDL. Okay, so bending moment diagram will be like this. This will be the bending moment diagram. So here again we will be having 2 points of contraflexure, one here, one here. These are the 2 points of contraflexure. Okay, probed cantilever beam loaded by UDL. So when a probed cantilever beam is loaded by UDL, okay, so bending moment diagram will be like this. Okay, so here also we will be seeing point of contraflexure like this. Clear? Okay, so there is only one case here. In this, there will be no points of contraflexure. Clear? Let's move on to the next question. What are the support reactions at the fixed end of the cantilever beam shown in the diagram below? Support reactions. Okay, support reactions. So we have to find out support reaction. So at fixed beam, how many support reactions will be there? At this fixed beam, there will be 3 support reactions. There can be 3 support reactions. What can be the 3 support reactions? Vertical reaction, horizontal reaction, and moment. Okay, but in this case, horizontal reaction will not come. Why? Because there is no horizontal force. So if there is no horizontal force on the beam, horizontal support reaction will not be developed. Okay, so we have to calculate only vertical support reaction and moment. Okay, so total load is 120 kilonewton. This total load is 120 kilonewton. When total downward load is 120 kilonewton, here support reaction will be how much? 120 kilonewton only. Okay, so if we do summation Fy equal to 0, I will be getting this support reaction 120 kilonewton only. Okay, so this wrong. Okay, now we have to calculate moment also. Okay, so how much moment will be generated here? Moment will be generated. See, this is the total load. Total load is 120 kilonewton. Okay, now if I want to calculate the moment, I can assume that this total entire load is concentrated at one point. It is concentrated at this point. Okay, so this point is 1 meter distance away. So this distance is 1 meter. Now if I want to calculate the moment will be equal to how much? 120 into perpendicular distance is 1 meter. Okay, so it will be 120 kilonewton meter. So correct answer will be option A. Both are 120. This is also 120 kilonewton. This is 120 kilonewton meter. Clear? So correct answer will be option A. Next question. For shear force to be uniform throughout the span of a simply supported beam, which of the following load should be applied on the beam? So for shear force to be uniform throughout the span, okay, simply supported beam. So we are having a simply supported beam. Just a minute. So we are having a simply supported beam. Okay, so this is the simply supported beam. Now on this beam, let us see two equally spaced concentrated loads. If I am having two equally spaced concentrated loads like this load and this load, how will be the shear force diagram? Shear force diagram will be like this. Shear force diagram will be like this. No. Sorry. This will be bending moment diagram. Shear force diagram will be like this. This will be the shear force diagram. Okay, if this value is P, this value is P, then this value will be P and this value will be P, and shear force will be equal to P. Okay, so this will be the shear force diagram. Okay, now what is asked? For shear force to be uniform. Shear force to be uniform. So in this case, is the shear force uniform? No. So shear force is not uniform. So that means this option A is rejected. Okay, so let us remove this. Let us remove this. Okay, now let us see other options. Second option, a couple at midspan only. So if I provide a couple at midspan, what will happen? Here I'll be having vertical reaction as m by L, vertical reaction upward. It will be in upward direction m by L, and this will be in downward direction, so it will be minus m by L. Okay, so my shear force diagram will be like this, negative m by L, okay. So shear force is uniform. Yes, shear force is uniform. Hi Ashwini. Okay, so shear force is uniform in this case, so correct answer will be this. But here they have written couple at midspan only. That means it implies that if my couple moves somewhere else, then this will not remain uniform. Is it saying this also? Couple at midspan only means if the couple is acting at midspan, then only I will be getting shear force as uniform. Otherwise, if I move this couple or if I apply this couple somewhere else in the beam, then I will not be getting uniform shear force. But let's move on to the option C, a couple anywhere in the span. So let us check if my couple is acting anywhere in the span, then also will I be getting the same? Okay, so if my couple is acting anywhere, then also this will be m by L only. The support reaction will be minus m by L only, and shear force diagram will be same, uniform, constant shear force. Okay, so that means couple can be applied anywhere. So correct answer will be option C, not B. Clear? Is it okay? So correct answer for this question will be option C. Let's move on to next question. Consider the simply supported beam AB subjected to the point loads of equal magnitude shown in the diagram below. So these are the 2 point loads of equal magnitude. Okay, this is the simply supported beam. Okay, the portion CD of the beam is, so portion CD of the beam, so we have to discuss about portion CD of the beam. So if we want to know about portion CD of the beam, let us draw the shear force diagram and bending moment diagram first. Okay, so shear force diagram, how will be the shear force diagram? Can you tell me? How will be the shear force diagram? See, support reaction, in this case support reaction will be W, RA is equal to W, and RB will also be equal to W. RA and RB equal to W. How we will get it? Equations of equilibrium. RA plus RB is equal to W plus W. So RA plus RB equal to 2W, and summation of moment about A, if you take summation of moment about A equal to 0, you will be getting RB is equal to W, and similarly by symmetry we will be getting RA equal to W. So RA and RB both we will get equal to W. Now if I want to find out the shear force diagram, so shear force diagram, if I take here at this location, what is the value of shear force? So shear force will be summation of all the forces to the right side of the section. Okay, so towards the right side of the section I am getting W. Now that means in this portion, in this entire portion, shear force will be constant. Now when shear force is constant in this entire region, that means, and the value is W. Now I have to find out what is the sign. Okay, so if magnitude is W and sign, this is what? This is giving me anti-clockwise rotation. Okay, this shear force will be giving me anti-clockwise rotation. That means it will be negative. So minus W. So here in this region from here to here, I will be getting negative and it will be minus W. And if I find out in this region, so if I take any section here, so what is the total summation of transverse forces to the right? W in upward direction, W in minus direction, cancelled out. So in this portion shear force will be 0, like this. And if I want to find out here, so it will be easy if I do summation from this side. So if I do summation from this side, this will be giving me positive clockwise rotation. Clockwise rotation, that means it will be positive and magnitude will be equal to W. Magnitude will be equal to W. Okay, so this will be the magnitude. So this will be positive. So this will be the shear force diagram. What will be the bending moment diagram? Bending moment diagram is also easy. This will be the bending moment diagram. Okay, now in this region, in the question they have asked about region CD. In region CD, shear force is 0. Okay, shear force is 0. In portion CD, shear force is 0. In portion CD, shear force is 0 and bending moment is constant. When shear force is 0 and bending moment is constant, that means it is in pure bending. It is in pure bending. Clear? Next question. What is the bending moment at A for the bent column shown in the figure given below? So this is the bent column. It is like this. Okay, and we have to find out bending moment at A. So bending moment will be equal to force into perpendicular distance. Force into perpendicular distance. Okay, so how much is the force? Force is 10 kilonewton. 10 kilonewton, and line of action of force is this. This is the line of action of force. Okay, so force is acting along this line. Okay, and from A, the perpendicular distance of this force, is 0. So 10 kilonewton into perpendicular distance is 0 meter. So 0 kilonewton meter, or just 0. So correct answer will be option D. Correct answer is option D. Is it clear? Yes or no? Clear? Let's move on to next question. The beam shown in the figure given below is subjected to concentrated load and clockwise couple. Okay, so this is the beam, and on this beam we are having two types of loading. One is concentrated load and another is couple 120 kilonewton meter. Now what is the vertical reaction at A? So if I want to find out the vertical reaction at A, there are two methods by which I can find out. So first method, I can use that summation of moment about B equal to 0. I can do summation of moment about B equal to 0. Okay. So if I do summation of moment about B equal to 0, so moment because of RA, it will be equal to RA into this perpendicular distance. So RA into, what is the perpendicular distance? 4 plus 2 plus 2, 8 meter. So RA into 8, okay, minus 50 into, again, perpendicular distance. So this force is having perpendicular distance of 4 meter. So minus 50 into 4, and this is, okay, now this RA is giving clockwise rotation. So I have taken positive, This 50 is giving anti-clockwise rotation. I have taken negative, and this 120 kilonewton meter again giving clockwise rotation. I am taking positive. So plus 120 kilonewton meter, that will be equal to 0. So RA will be equal to 50 into 4. How much? 200. So minus 200 plus 120. It will be minus 80. So minus 80. 80 gone there. So RA will be equal to 10 kilonewton. RA is 10 kilonewton. Clear? So this is one method. Okay. Another method I can calculate separately for both. Okay. So I can draw beam like this. This is RA. This is RB. Okay. So first I'll write 50 kilonewton. Okay. Separately for this and separately for this. Let us say RA1, RB1, RA2 and RB2. Okay, and because of this 120 kilonewton meter, I can calculate separately, and then by principle of superposition, I can add both RA1 and RA2 to get RA. So RA will be equal to RA1 plus RA2. Okay, so RA1, this is acting at midpoint. This is acting at midpoint. So this will be 25 kilonewton. This will be 25 kilonewton. So 25 kilonewton. Okay. Plus RA2. It will be minus M by L. Okay. So it will be minus 120 by L. Length is how much? 8. So 25 minus 120 by 8. How much is the 120 by 8? Just a minute. 15. So it will be 25 minus 15. So I'll be getting 25 minus 15, 10 kilonewton. 10 kilonewton. So RA will be equal to 10 kilonewton. So from both the methods you can find out, answer will be same. Let's move on to next question. Couple M is applied at C. So at this point C, a couple M is applied on a simply supported beam AB. So this is the simply supported beam AB. Couple is applied. What is the maximum shear force for the beam? Okay, so here support reaction will be, in this case, this couple is, anti-clockwise. So here I will be getting plus M by L, and here I will be getting minus M by L. Okay, so the maximum shear force will be M by L only. M by L. Okay, so length is 3 meter. So it will be M by 3 plus M by 3, and this will be minus M by 3. Correct answer will be option D. Option D is the correct answer. Clear? Next question. A cantilever beam AB carries loading as shown in the figure below. Okay, so loading is this on a cantilever beam. Which one of the following is the shear force diagram for the beam? So I have to draw the shear force diagram. So if I want to find out the shear force at this location in CB portion, if I want to find out the shear force in portion CB, so if I find out all the transverse forces towards the right of this section, transverse forces is 0. Okay, this is moment, not transverse force. Okay, that means summation of transverse forces towards this side is 0. Okay, so any general section if we take in portion CB, the transverse force will be 0. Okay, so that means here in this region there is 0 shear force. And again, and now if I want to find out in portion AC, so let us take any general section, and transverse force towards the right will be equal to 2 kilonewton. And this 2 kilonewton will be giving me clockwise rotation, so it will be positive. So shear force diagram will be something like this, that in this region I will be getting plus 2 kilonewton, and in this region I will be having 0. Okay, so this is 2 kilonewton. So let us see what are the options. Correct answer will be option A. 2 kilonewton here constant, and from here to here it will be 0. Hello Anubhav, how are you? Are you able to understand? Okay, let's move on to the next question. If you are having any doubt in any question, you can ask me. Okay, now cantilever AB is loaded as shown in the figure given below. So this is the cantilever beam AB. Okay, what is the shape of the bending moment diagram for portion AC? So for this portion AC, just think what will be the bending moment diagram. What will be the bending moment diagram for portion AC? Just think. So options are parabolic, linearly varying with maximum value of bending moment at C, linear with constant bending moment value from C to A. So from C to A, linear with constant bending moment value. How can it be linear? Means it will be just straight line. Linearly varying with maximum value at A. So what will be the correct answer? So for this portion, we have uniformly distributed load. So shear force diagram will be linear or triangular. Okay, bending moment diagram will be parabolic. So in this portion, bending moment diagram, in BC portion, bending moment diagram will be parabolic. Here there is no loading, so it will be linear like this, linearly varying. Maximum bending moment will be at A. So correct answer will be option D, linearly varying with maximum value at A. So we have been asked, question was for this region. Okay, for this region. So in this region, we are having linear variation with maximum value at A. Okay, clear? So this is linear, or we can say 1 degree, and this is parabolic 2 degree. Right? स्ट्रक्चर एनालिसिस बहुत अच्छा पढ़ा है, थैंक यू सो मच. चलो आपको अच्छा लगा, इससे अच्छी बात क्या हो सकती है. चलिए नेक्स्ट क्वेश्चन, पराक्रम बैच बी. ओके नाइस. चलिए लेट्स मूव ऑन टू नेक्स्ट क्वेश्चन. फॉर सिंपली सपोर्टेड बीम शोन इन द figure given below, at what distance from the support A is the shear force 0? So can you tell me? So this question you should know the answer. Okay, you should remember the answer, but we will calculate also. How to calculate? First we have to find out what are the support reactions. Okay, so what are the support reactions? Support reaction at A, how much is the support reaction at A, and how much is the support reaction at B? So RA is equal to WL by 6, and RB, support reaction at B, is WL by 3. Now if you don't know the support reaction, we can easily calculate. Convert this entire load into a point load. How much is the load? Will be the area of this triangle. Area of this triangle is half base into height. 10th क्लास में भी क्लास देख लेते हैं कभी कभी, समझ में आ जाता है. चलो ओके, सो this load, total load will be WL by 2. Now if I take support reaction as force into opposite length by total length, okay, then we can easily find. Okay, so this we will be getting RA WL by 6 and RB WL by 3, okay, by using this. Okay, so RA and RB are clear. Now let us take any general section here at distance x, and let us find out what is the value of shear force at this section xx. Okay, so shear force at section xx will be equal to how much? Let us calculate from this side. So from this side I will be getting RA. RA is giving me clockwise rotation, so it will be positive. So plus RA minus this total loading. So here the loading intensity is W. At this location, what will be the loading intensity? What will be the loading intensity at this location? See, it is linearly varying from 0 to W in total length L. So in X length, it will be becoming W by L into X. So here loading intensity will be W by L into X. Is it clear? So this is linear interpolation. If I follow linear interpolation, or I can use similar triangle method also. By similar triangles or linear interpolation, here the loading intensity will be Wx by L. Now this total load will be half base into height. So it will be half into base. Base is how much? X. Height is how much? Wx by L. Wx by L. Okay, so shear force at x. Now at what distance x shear force will be 0? So I have to put shear force at x equal to 0. So 0, what will be the value of Ra? WL by 6 minus, I have to put it capital W. Okay, in question it is given capital W. So to capital W L by 6 minus W x square by 2L. Okay, so this is equal to 0. From here I can calculate value of x. So this capital W and capital W will get cancelled out. I'll be getting x square is equal to L square by 3, x is equal to L by root 3. Correct answer will be this. So you have to remember this result. Okay, if any time it comes in the examination, you should not be solving this. Okay, you should remember this result. Let's move on to next question. I think it is clear. Next question. Okay, in the first class of SFD BMD I have derived this. Okay, so now again I am not going to derive this result. You should remember again, this is also a result that you should remember. A uniform beam of span L carries a uniformly distributed load W per unit length as shown in the figure given below. The supports are at a distance of x from either end. What is the condition for maximum bending moment in the beam to be as small as possible? So maximum bending moment will be as small as possible when maximum negative bending moment at this location becomes equal to maximum positive bending moment at this location. Good evening, Love Kumar. How are you? Now, have you understood what is the condition? That maximum bending moment will be minimum as possible, Here, maximum negative bending moment, magnitude of maximum negative bending moment should be equal to magnitude of maximum positive bending moment. Now, if I solve this, I will be getting x is equal to 0.207 L. Now, just tell me if you want that I should derive this. You want the entire derivation, or should we move on to the next question? Tell me. If you want, I can derive also. Okay, let's move on to the next question because I have already derived in previous class. Okay. Next question. Which one of the following is the bending moment diagram for the vertical cantilever beam loaded as shown in the figure below? Okay, so this is the cantilever beam, cantilever column, this cantilever column. Okay, sir, Ashoka batch A ka revision. Yes, you can do revision for Ashoka batch A. Okay, and if you are having any doubt in sign convention or in calculation or any other doubt, you can ask. Okay, so I have from starting itself I have told you in Telegram group also that engineering services questions are, you know, very good practice ground for your AJE questions also. Okay, only few questions are difficult ones that you can leave, but most of the questions in prelims, okay, most of the questions, where many of the questions will be matching your level only. Many a times you will see that in AJE examinations, as it is, ESE questions are asked as it is without even change of data. So it is very much advisable to solve ESE prelims questions for your AJE examination practice also. Okay, many teachers will be saying this, almost all the teachers will be saying this, that in youth also they have given many of the ESE questions. Okay, and that youth book is for your AJE preparation. Okay, now this column is cantilever column. Okay, this column is cantilever column. Okay, here fixed support and this is column, and here one bracket is attached. On this, load of 10 kilonewton is applied. When this load of 10 kilonewton is applied, can you tell me how much bending moment will be generated here at point C? How much bending moment will be generated? 10 into perpendicular distance. Okay, force into perpendicular distance. How much is the moment generated here? 10 into 0.3. That means 3 kilonewton meter. And this perpendicular distance is not changing. For this, perpendicular distance is same. For this section, perpendicular distance is same. For this section, perpendicular distance is same. So that means throughout this length, CB length, my value of bending moment will be 10 into 0.3. That means 3 kilonewton meter. Yes or no? 3 kilonewton meter. This will be the value of bending moment in this region. Okay. Here at point B. Okay, so this value, this is the bending moment in this portion. Okay, what is the value? 3 kilonewton meter. Okay, so from the reference line, I will be drawing this magnitude will be like this. Okay, in beam, if my reference line is this, so I draw magnitude perpendicular to the reference line. Okay, so here reference line is this, magnitude will be perpendicular to the reference line. Is it clear? Now, after point B, now because of this 10 kilonewton, here also I will be getting 3 kilonewton meter. Here also 3 kilonewton meter, here also 3 kilo, everywhere 3 kilonewton meter because of this 10 kilonewton. But for portion BA, I will be getting an additional moment. BA के लिए additional moment मिल जाएगा. I will be getting an additional moment in this portion. So the value will be 5 into 0.6. 5 into 0.6. How much will be 5 into 0.6? 5 into 0.6 will be again 3 kilonewton meter. 3 kilonewton meter, but this will be in opposite sense. Okay, this was giving me rotation like this. Okay, like this, anti-clockwise. Okay, this will be clockwise. Okay, so based on the reference phase, this can be positive or negative, but whatever sign I am taking, if it is positive, then this will be negative, and if this is negative, then this will be positive. Okay, so opposite, equal and opposite I will be getting, so it will be becoming 0. So in this portion, my bending moment value will be 0. Is it clear or not? Is it clear? Any doubt? So I will be getting answer A. Option A will be the correct answer. Option A will be the correct answer. Clear or not? Clear? Okay, I hope it is clear. Let's move on to the next question. A simply supported beam AB, this is the AB, simply supported beam AB, has span L as shown in the figure below. So total span of the beam is L. Okay, very good. Okay, point C is the midspan of the beam. So this is the point C, it is a midspan of the beam. It is subjected to UDL, W per unit length, in portion A to C. So from A to C, UDL, okay, now which of the following are SFD and BMD of the beam? Now, if you want to find out the shear force diagrams, first we have to calculate the support reactions. So support reaction, what will be the support reaction at A? What will be the support reaction at B? So RA will be equal to WL by 2 is total load into opposite length will be 3L by 2, 3L by 4. Opposite length will be 3L by 4. So WL by 2 into 3L by 4. WL by 2 into 3L by 4, and total length will be L. So I will be getting W3 WL by 8. Okay, and here I will be getting 5 WL by 8. No. 3 WL by 8. Just a minute, let me calculate. See, let's leave the values. Okay, here I will be getting it was correct, no? This is 3 WL by 8, and total load is WL by 2. So WL by 2 minus 3 WL by 8. How much support reaction I will be getting at RB? At RB, my support reaction will be WL by 8 only. it will be WL by 8. So 3WL by 8 plus WL by 8, 4WL by 8, that means WL by 2. So total load is WL by 2. So this is 3WL by 8, this will be WL by 8. Is it clear? How we have got these support reactions, are you able to understand? Support reactions RA and RB, are these clear? This support reaction will be total load. See, this total load is how much? This total load can be replaced by point load. It will be WL by 2. Loading intensity is W and length is L by 2. So WL by 2. Okay. This distance will be 3L by 4. So load into opposite length divided by total length. Opposite length is 3L by 4. If I do, this is L by 4, this is L by 2. Okay. So support reactions, I think, are clear. Okay. Now, when we have got support reactions, now if I want to find out shear force diagram, so shear force diagram will be like this. This is 3WL by 8. Here sudden jump will be there. Okay. And from here to here, it will decrease slowly, and it will decrease like this. Here I will be getting sudden jump, and here it will be like this, and from here to here it will be constant, and here like this. Okay. So this will be the shear force diagram. Here it will be 3WL by 8. Here it will be WL by 8. Okay. This will be positive, this will be negative. Shear force diagram clear or not? So this is the shear force diagram. So just by shear force diagram also we can eliminate. Okay, shear force diagram. So this shear force diagram is wrong. This shear force diagram is wrong. This shear force diagram is wrong. Okay, only one shear force diagram is correct. So now if you don't even draw the bending moment diagram, then also you will be able to get it. Okay, but in this portion, you know, UDL is acting. So in this portion, bending moment diagram will be parabolic, and here there is no loading. So in this portion, bending moment will be linear, straight line or triangular. Okay. So here it will be parabolic here, and it will be straight line in this portion. Okay. So this is the correct answer. Option A is correct answer. Both shear force diagram and bending moment diagram are matching. Right. Let's move on to the next question. At what distance from the left support of the beam shown below is the shear force 0? This is the left support, and from at what distance I will be getting shear force 0. So let us first calculate the support reaction. What will be the support reaction? So support reaction, let us say this is RA. So if I do summation of moment about B equal to 0, if I do summation of moment about B equal to 0, or simply I can do load into opposite length by total length. Both the methods I can use. Okay, so here I will be using summation of moment about B equal to 0. Summation of moment about B is equal to 0. If I do summation of moment about B equal to 0, I will be getting, because of RA, I am getting clockwise moment. Let us take clockwise moment. So here I am not saying bending moment at B equal to 0. What I am saying, summation of moment about B equal to 0. So sign convention of moment will be used, not bending moment. So moment sign convention I can take any. I can take clockwise positive or I can take clockwise negative. So right now I am taking clockwise as positive. Yeah, questions practice only. Questions practice. But if you want any theory, if you want some concept to be revised, I can revise that concept also. It's your demand. Okay, but right now I am doing all the questions practice. So from questions only, strength of materials is basically numerical topic. Okay, so if you solve all the questions practice के अंदर ही concept भी हो जाएगा, right? Okay, so RA की वजह से कितना moment आ जाएगा? What will be the moment because of RA? RA into perpendicular distance. So perpendicular distance RA into, what is the perpendicular distance? 4 meter. So RA into 4. Okay, minus, what is the total load here? Total load is 15 into 2. So minus 15 into 2. Now because of this UDL, we will be getting anti-clockwise movement. Anti-clockwise movement because of this. So minus, because it is anti-clockwise, load value is 15 into 2. And perpendicular distance will be here centroid पर होगा. Okay, so this will be 1 meter. So distance of centroid from here will be 3 meter. So minus 15 into 2 into 3 will be equal to 0. So RA will be equal to 45 by 2, that means 22.5 kilonewton. 22.5 kilonewton. kilonewton. Okay, so support reaction RA is equal to 22.5 kilonewton. Now 22.5 kilonewton here. So shear force diagram, what is at what location is the shear force 0? If this is 22.5 kilonewton, so shear force diagram will be something like this. Okay, now I have to find out at what distance will the shear force become 0. Okay, so let us say at x distance shear force is becoming 0. Okay, at x distance from this support, let us say shear force is becoming 0. So if I want to find out, let us take this section as xx. Okay, so shear force at xx will be equal to how much? RA. RA will be, because of RA, shear force at this will be positive or negative? Tell me. Because of RA, it is in upward direction. Okay, support reaction at A, this is in upward direction. Now because of this RA, shear force at X will be positive or negative? It will be positive. Why? Because this RA will be giving clockwise rotation. Okay, yes, it is positive. So because of RA, it will be positive. Positive, what is the magnitude? 22.5 plus 22.5 minus. Okay, because of this UDL, I will be getting minus because it is giving me anti-clockwise rotation. So minus, now what will be the total shear force at this section because of this UDL? So loading intensity into this distance x will be multiplied. Okay, yes. So loading intensity is 15 into x. Now shear force at x is equal to 0. So 0 is equal to 22.5 minus 15x. So x will be equal to 22.5 divided by 15. Okay, so we can calculate 22.5 divided by 15. I'll be getting 3 by 2. That means 1.5 meter. So x will be equal to 1.5 meter. So at 1.5 meter, I'll be getting shear force at this section 0. Okay, so this will be 1.5 meters from here. Is it clear? Let's move on to next question. Okay, just a minute. For the simply supported beam in the figure below, C is the center of the span. So this C is the center of the span. C is also the point through which the resultant of the column load W. So this is a column. Okay, this is the column. So this column area will be very small. Column area will be very small, but load will be high. Okay, so generally column load is taken as point load. Generally we take column load as point load, but in this question they have shown column as some, means they have not ignored, they have not neglected the dimensions of the column. But generally if column is acting like this, we consider it as a point load. But in this case, this load W is acting at some area, So if we want to convert this into, just a minute, if we want to convert this into loading, what we will do, we will convert this column into UDL. Okay, at very small dimensions, okay, very small length, but it will be UDL. Okay, so total load will be W, and this will be considered as UDL. Now if I want to draw the shear force diagram, what is the shearing force at C? At point C, I want to draw the shear force diagram. So if I want to draw the shear force diagram at C, my shear force diagram will be, so this will be W by 2 here. Okay, this will be W by 2. Okay, because it is symmetrical, L by 2, L by 2. Okay, so here I'll be getting shear force W by 2 from here to here up to this location, up to this location. So up to this location it will be constant, but from here what will happen? My shear force diagram will reduce like this. Okay, shear force diagram will go on reducing like this, and from here to here it will be like this. So this will be the shear force diagram. So this will be W by 2, this will be W by 2, this will be negative W by 2, this will be positive W by 2. Okay, so at location C, here shear force is 0. Shear force is 0. So at point C, shear force will be 0. Is it clear? So correct answer will be option D. Correct answer will be option D, right? Okay, so these much are the questions in today's class. So let us wind up the class today here itself. Let's meet up in the next class. So we are having regular classes on Tuesday, Thursday and Saturday. Okay, regular classes on Tuesday, Thursday and Saturday. Live classes. Okay, so your doubts will be solved. If you are having any doubts, you can ask here, and if you are not having any doubts, then also you can practice questions. Okay, practicing questions is very necessary to clear your examinations. Okay, so let's meet in the next class. Okay, till then, bye bye, take care, see you in the next class.